Electrospinning is a common microfabrication technique capable of easily creating two-dimensional fiber meshes with controlled size and orientation. However, for biomedical materials or energy applications, the standard setup is commonly not able to fabricate three-dimensional fiber scaffolds without compromising the special architecture and porosity. Taking this into account, we propose a new collector system that uses an adjustable set of electrodes to tune the electrostatic field in order to customize the fiber orientation, and a controlled vacuum system to hold the lined fibers to the descending collector table, sequentially constructing additional layers with programmable patterns depending on the electrode's geometry. This pattern efficiently provides thick three-dimensional fibrous scaffolds with an accurate depth-dependent orientation and a high process reproducibility.